The molecular decision that shaped the modern world. It looked like a technical choice, a reaction pathway selected over another, a yield optimized, a variable fixed. At the molecular level, the decision seemed narrow, almost trivial, but once made, it reshaped everything built on top of it. At the time, no one framed it as world-changing. Chemists make molecular decisions constantly. Which bonds to favor, which conditions to stabilize, which reactions to accelerate or suppress. Most of these choices remain confined to labs, papers, and industrial processes. They improve efficiency, reduce cost, or simplify production. This one did all of that, and far more. What distinguished it was not novelty, but compatibility. It fit perfectly into constraints of its era, and because it fit, it spread. Compatibility is rarely treated as power, yet it is one of the strongest forces in chemistry. A reaction that aligns with existing temperatures, pressures, materials, and skills does not need persuasion. It propagates naturally. This molecular pathway did not demand new infrastructure or radical retraining. It slipped into place, reinforcing systems already in motion. Because it required so little adjustment, it encountered almost no resistance. To understand why this mattered, we need to recognize how deeply modern civilization depends on chemistry behaving predictably at scale. Energy systems, agriculture, medicine, manufacturing, and infrastructure all rest on molecular behavior repeated billions of times. When one reaction pathway becomes dominant, everything downstream reorganizes around it. Equipment is redesigned, training adjusts, supply chains realign. Alternatives slowly disappear, not because they failed, but because they no longer fit the dominant chemistry. Once a pathway becomes standard, it quietly defines what is possible. Designers stop asking what could be built and start asking what fits. Engineers optimize within the chemistry they are given. Investors fund what scales easily. Over time, imagination bends toward feasibility, and feasibility bends toward the existing molecular logic. The molecular decision did not impose itself. It was chosen because it worked better under immediate constraints. It produced consistent results. It scaled efficiently. It integrated smoothly with existing systems. In isolation, it was a rational choice. In context, it became the default. And defaults are powerful precisely because they feel neutral. Once established, they stop looking like decisions at all. Once adopted widely, the decision hardened into infrastructure. Factories were built to support it. Machinery was calibrated around it. Education trained generations to think within its logic. Research focused on refining it further rather than questioning its foundations. The molecular pathway stopped being one option among many and became the baseline assumption. New innovations were judged by how well they aligned with it, not whether they offered fundamentally different possibilities. This is where its influence expanded beyond chemistry. Molecular decisions are never neutral. They privilege certain outcomes and suppress others. They favor specific inputs, temperatures, pressures, and timelines. Over time, they shape not just products, but possibilities. What is easy to make becomes abundant. What is difficult to make fades away. Innovation narrows quietly, guided less by imagination than by chemical compatibility. As this pathway spread, entire economic structures reorganized around it. Raw materials were extracted to feed it. Transportation systems optimized for its outputs. Waste management adapted to its byproducts. None of these systems were designed independently. They co-evolved around the same molecular assumption, reinforcing one another until deviation became costly. The modern world absorbed this decision without noticing. Products became cheaper. Processes became faster. Systems grew more reliable. The benefits were immediate and measurable. The costs were delayed, diffuse, and easy to ignore. Efficiency was visible. Structural dependency was not. At scale, the molecular choice altered how resources were extracted, transformed, and discarded. It changed energy density. It extended material lifespans. It reshaped waste streams and environmental persistence. None of these effects were catastrophic on their own. Together, they rewrote entire ecosystems, economic, social, and biological. Chemistry quietly became policy without ever being debated as such. What made this especially powerful was its invisibility. People interacted with outcomes, not pathways. Convenience masked dependency. Reliability obscured fragility. The molecular decision operated beneath awareness, shaping behavior while escaping scrutiny. It became part of the background assumptions of modern life. As systems adapted, feedback loops formed. Because the decision worked well, everything leaned into it harder. Redundancy was reduced. Alternatives were no longer maintained. Resilience was traded for optimization. The pathway became self-reinforcing, not because it was flawless, but because nothing else was left intact. This created lock-in. Changing course became increasingly expensive. Reintroducing alternative pathways meant rebuilding entire systems from the ground up. Skills had to be relearned, equipment replaced, supply chains reimagined. What had once been a choice now looked like necessity. Over time, the question shifted from "is this the best option?" to "how could anything else even work?" The conflict emerged as unintended consequences accumulated. Environmental strain, resource concentration, persistent waste, health effects that appeared statistically but not dramatically. None of these could be traced cleanly back to the original molecular decision, because decades of layers had grown on top of it. Cause and consequence drifted apart in time, making accountability diffuse. Attempts to address the symptoms rarely touched the foundation. Regulations targeted outputs. Innovations optimized around the same pathway. Solutions assumed the molecular choice was fixed because questioning it felt unrealistic. Chemistry had become background truth rather than deliberate decision. The realization came slowly and uncomfortably. The modern world had not been shaped only by politics or economics. It had been shaped by a molecular decision. A choice about how atoms should bond, break, and rearrange it quietly dictated how societies organized production, distribution, and consumption. Power followed those who controlled the pathway. Dependence followed those who did not. Influence flowed through chemistry long before it appeared in markets or policy. The emotional weight of this insight lies in its humility. No villain made the decision. No conspiracy enforced it. It emerged from rational optimization within narrow constraints. Chemistry did exactly what it was asked to do. The outcome was not malicious. It was cumulative. The problem was not the decision itself. It was its scale. When molecular choices propagate globally, they stop being technical. They become civilizational. They determine what is cheap, what is abundant, what is disposable, and what is rare. They shape labor, trade, and environmental impact without ever entering public debate as choices at all. The climax of this story is recognition. The modern world is governed not only by laws and markets, but by reactions chosen long ago and rarely revisited. Power flows through molecules as much as institutions. Control is exercised not only through policy, but through chemistry embedded so deeply it feels natural. The resolution is not reversal. The molecular decision cannot simply be undone. Too much depends on it. But awareness changes how future decisions are made. It introduces caution where blind optimization once ruled. It restores the idea that efficiency is never free, only deferred. Chemistry will always require choices. Reactions will always be selected. The lesson is not to fear those decisions, but to recognize their reach. What begins as a molecular optimization can end as a global constraint. The modern world will shape one reaction at a time, and the next molecular decision will shape whatever comes next.